Section 4.1, Solving of Inequalities. We now modify our equation solving skills for the solving of inequalities. An inequality is any sentence containing a less than, a greater than, a less than or equal to, a greater than or equal to, or a not equal to. Any value for the variable that makes an inequality true is called a solution. The set of all solutions, and that's what's unique to an inequality, is that there is more than one answer, is called a solution set. Let's take a look at this problem. They're asking us, would any one of these numbers be solutions for this inequality with a greater than or equal to? So we're going to plug in values for the x. We'll let x equal 0 in the first to see if we have a solution. Multiplying, we get a 0 minus 2, which is a negative 2, is not greater than 4, so we would say no on 0 being a solution. Replacing x with a 2 for the next value, see if we get a true expression. Multiplying 6 minus 2 gives us 4. It's not greater than 4, but because this inequality has the equal portion of it, it does satisfy the 4 equal to 4, so we would say yes, 2 is a solution. Letting x be a negative 1 and testing it, multiplying, we get a negative 3 minus 2, or plus a negative 2, is giving us a negative 5 greater than or equal to 4. Never the case. And if you looked at it, the smaller the value, since 0 didn't work, it makes sense that the smaller we go is not going to garner a true value either. Let's test the 4 then, the last value that they're asking us here. 3 times 4, when we replace the x with 4, gives us a 12 minus 2, which is 10 greater than or equal to 4. Yes. So the values that are solution to this inequality would be the 2 and the 4 that we had. Now we have inequalities written here using the inequality symbol, but we have another way that we can write an inequality, and it's using something known as the interval notation. The interval notation uses parentheses when we have an open interval, and we use brackets when we have a closed interval. And let me show you what this looks like. When we have an inequality here, for example, x is greater than 3. Let me draw a number line to represent what set of numbers we're talking about here. Any value that's greater than 3 is going to be part of this solution. It will continue infinitely and head towards infinity for that matter, except we're not including 3, so I have an open point here. In interval notation, you always write your smallest value first, your end value or your largest value second, and because we're not including the 3, we use the parenthesis because of this being an open interval. Infinity, because it does not end, also will use the parenthesis when we express this inequality using interval notation. I have another example here with x is greater than or equal to 5 and less than or equal to 6. Let me draw a number line for that as well, so we get a sense of what numbers we're talking about. X is greater than or equal to, so we have a solid point, and less than or equal to 6. So we have a solid point at 6 because it's included in the solution. Interval notation, again, you put your smallest value on the left, largest value on the right. This time, because we are including the 5, it is a closed interval. We use a bracket to represent that, and same with 6, we are including the 6 with that as well. We can take and use the interval notation to translate these set builder notations. They're giving us the set of all x's such that x is greater than 1. Again, let me draw a number line just to give us a sense of what set of numbers we're talking about. We're not including 1, but anything right up to, or I should say past 1, is part of our solution. It's headed towards positive infinity. For interval notation then, our smallest value is 1. Our largest value is ever increasing. We use the positive infinity to represent that. We're not including the 1, so we have an open interval expressed or designated by the parenthesis, and infinity, because it never ends, we use the parenthesis for that as well. In this next example, we have the set all values of x such that x is less than or equal to -4. Graphical representation, x is less than or equal to. The equal to means we'll use a solid point, and less than is headed off to the left, and it's going towards negative infinity because it's ever getting smaller. Interval notation for this set builder, our smallest value is this negative infinity. The highest value is -4. Infinity, because it never ends, will always have a parenthesis in interval notation. And in this particular problem, because our inequality included the value of -4, we indicate that with the bracket. This is actually called a half-open interval. The last example here, translating the set builder notation, is the interval x greater than 5 and less than or equal to 6. A number line representation of this would be the numbers between 5 and 6, not including 5, but including 6. The not including because the less than for the 5, the including 6 because the less than or equal to 6. Interval notation, smallest value, largest value for your interval or solutions, not including the 5, indicated with the open interval parenthesis, including the 6, we use the bracket, and this also would be an example of a half open interval as well. When we solve inequalities, we basically use the same procedures that we did with solving an equality. And just as the addition principle for equations produces equivalent equations, the addition principle for inequalities produce equivalent inequalities. So that stated is, if A is greater than B, then adding the same quantity to both sides of the inequality maintains that inequality. And it doesn't matter if it's a greater than or if it starts out as a less than. If you add the same quantity to both sides, the inequality is going to, whoops, that has to be a B, the inequality will be maintained. Multiplication or division principle for inequalities has a little bit of a special handling, different for inequality than with equality because of the multiplication by a negative number. Let's look at an example. If I have the statement 4 is less than 9, and I multiply both sides by 2, 9 times 2, I end up with 4 times 2 is 8, 9 times 2 is 18. 4 was less than 9. Multiplying both sides by 2 gives us a true statement. 8 is still less than 18. But if I start with 4 is less than 9 again, but this time I multiply by a -1 on both sides, 4 times -1 is -4. 9 times -1 is -9. Well, 4 is less than 9 was true, but multiplying by a negative, all of a sudden we have -4 is less than -9. On the number line, here's -9, here's -4. Anything to the right is greater than numbers to the left, So we have a false statement. And when that occurs, we need to reverse the direction of the inequality to keep our inequality statement true. So that garners a rule when we're doing our multiplication. So here's the statement for the multiplication principle for inequalities. If you have an inequality and C is greater than 0, any number greater than 0 is understood to be positive, then A times C is less than B times C. Nothing needs to be done. The inequality stays true to the inequality as long as we're multiplying by a positive number. But as we just saw in this example, if we start out with an inequality and we multiply by a value that is negative, and a way of representing a negative number is to say that it is less than 0. So the implication here is we're multiplying by a negative 0, or a negative number. We have A times C and B times C. Whatever the direction of the inequality was prior to the multiplication by a negative, it will be reversed. So we started with a less than. To maintain that inequality, we would have to reverse that. So on this example that I had, 4 is less than 9, multiplying both sides by negative 1, because I didn't change the direction, I had a false statement. To hold for the multiplication principle of inequality, recognizing a multiplication by a negative, I should have automatically, by the principle, changed the direction, and then we would have had a true value. Next, we are going to then use these principles to solve some problems. They're asking us to solve this inequality. I want to get the variable by itself. I'm going to add the same quantity to both sides. X is less than 4 plus 1 or 5. They're asking us to graph that. So here a simple number line, all the values less than 5 right up to but not including or indicated by an open point, and we want them less, so it's headed towards negative infinity. And then they want set builder notation, so we will say all the values of x such that x is, and we can simply put the simplification of our answer, and they want interval notation. And when I'm graphing, I don't need to indicate a negative infinity, but it helps when you're writing your interval notation. You always want to put your smallest value first, your largest value second. Infinity is never closed, and because we're not including the 5, we'll use a parenthesis as well. In this next example, solving. For the variable, the only thing happening is a multiplication by 6, so we'll divide both sides by 6. Negative divided by positive, 30 divided by 6 is negative 5. Graphically, what does that look like? Here's our number line. X is less than or equal to negative 5. Since it's less than or equal to, we'll use a solid point, and less than is headed off to the left. So there's a graph. Solution expressed in set builder notation would be all the values of x such that x is less than or equal to negative 5. All we need is some kind of rule. You could write that out if you wanted to. And then interval notation, how low do we go? We're headed towards negative infinity, never ending, but ever getting smaller, to a high of, or maximum value of negative 5. Because it's infinity, always the parenthesis. Because it's a less than or equal to, we will use a bracket. The last example that I have here is to solve this inequality. We have a multiplication by negative 5. We always want to solve for a coefficient of positive 1 on our variable. So what I do to one side, I do to the other. And here's that special case for the multiplication principle of inequalities. If we are dividing by a negative, no problem, but make sure to maintain that inequality that we change the direction of the inequality. So we started with a greater than, it will be a less than. Simplifying then, the negatives cancel out, 5 over 5 cancels out, leaving a 1x, or just expressed as x. 25 divided by negative 5, a positive divided by a negative is a negative, and 25 divided by 5 is 5. So our solution is x is less than negative 5. Number line wise, we're here at negative 5. We're not including it. It's all the values right up to, but not including negative 5, and headed towards negative infinity as well. For a set builder notation representation of our solution, we would say all set of x values such that x is less than negative 5. And interval notation, everything seems to be a less than in this set of examples I have here, so no surprise, our smallest value is negative infinity. We're going up to, but not including negative 5. The not including is the parenthesis. Inequality is always a parenthesis on that as well. The other thing that we can look at is more complication on solving inequalities. And here we have a little more complexity. Nothing can be done currently on the left, but on the right, our first priority would be to get rid of the parentheses. And to do that, we'll use the distributive property. Negative times the positive is negative. 5 times 4 is 20x. A negative 5 times the negative 1 is a positive 5. We have variables on both sides, so we want to get it to one side. It doesn't matter which direction. A lot of people like seeing the variable on the left-hand side. So let's add a 20x just as long as we maintain equality. So simplifying, we have a negative 25 plus 20 still leaves us on the negative side of things. Plus 25 is less than or equal to a positive 5. Adding and subtracting doesn't change our direction of our inequality. And we have the x's on one side, but we need to get x by itself. So first step is to get rid of the 25. That's gone, still leaving our negative 5x less than or equal to 5 plus negative 25 is negative 20. Solving for the positive variable, we'll divide both sides by negative 5, and hopefully the buzzers and flashers are going off. I just divided by a negative, which means the direction of the inequality needs to be reversed. It was a less than, it is now a greater than. Negatives cancel out, 5's cancel out, leaving x. Negatives cancel out, 20 divided by 5 leaves us with a 4. Graphically, what does that look like? Here's our number line. We want all of the x's greater than or equal to 4, so we'll use a solid point and greater. There's our graph. It is headed to positive infinity. Set builder notation, we want the set of all x's such that x is, there's our rule, greater than or equal to 4. And last, interval notation, the smallest value is 4. It's headed towards positive infinity. We're including 4, use a bracket, infinity, always the parenthesis. This last example of solving an inequality starts with what looks like a fraction. We can simplify that first by multiplying by the least common denominator. There is only one denominator, so to clear the fractions, first step is to multiply every term by that least common denominator, which in this case is 5. The 5 is understood to have a 1 in the denominator, so the 5s are canceling out. That was the whole idea. It leaves us with our numerator of 4x plus 1, greater than or equal to, a negative times a positive is negative, 2 times 5 is 10. It looks much nicer as far as solving now. There's nothing to simplify. The variables are on one side, so the only thing we need to do is to get x by itself. And the first thing, we'll peel away the plus 1 by subtracting 1. That leaves with a 4x greater than or equal to a negative 10 minus 1, or a negative 10 plus a negative 1 if you use the rule of division. That adds up to be a negative 11. And then dividing both sides by 4 to get x by itself, and dividing by a positive number. We don't have to concern ourselves with changing the inequality direction. We end up with a negative 11 fourths. And we can leave it simply as that fractional or rational number representation. Graphically, what does that look like? We're on the negative side here at negative 11 fourths, greater than or equal to. We're including that. Our graph is greater than, so it's headed towards positive infinity. Set builder notation, all the values of x such that x is greater than or equal to negative 11 fourths. And you certainly could express that as a decimal equivalency. And interval notation, the smallest value is negative 11 fourths. It's headed infinitely in the positive direction, so we'll put positive infinity. We are including the negative 11 fourths, so for interval notation we'll use a bracket on the first side and a parenthesis on the second side. The last thing that we will look at is translating an inequality. There's a lot of times when we have applications, and just as a little practice here on the class notes, the first one I have here is recognizing the verbiage or the words that are used to indicate an inequality versus the equality that we've seen before, and they're asking us for a number that is less than 8. So here's our indication of putting a variable, an unknown, a number, don't know what that is, choosing x, is less than is the inequality way of representing this inequality symbol, and then of course 8. So you will see some practice problems dealing with translating very simple inequality expressions. And then application-wise, I have another example here, and it's asking us in this sample, or telling us, I guess I should say, a student is taking a biology class in which there will be 4 exams. She has test scores of 68, 76, and 78 on the first 3 exams. What must she score on the last exam to earn a B, which is calculated at 80 or better in the course? So a lot of you probably have had this same kind of situation. Let's see what it looks like. We're asked what is that 4th test score, so I'll let that represent our unknown. So x is equal to the 4th test score, and think about how the grades are calculated. We would add up the 3 scores that we know plus that 4th unknown. How do you average? And it says the score is based on an 80% or better. So we would add up the 4 scores, divide by 4, and the student wants to earn a B or better, so it needs to be 80 or better. So it's not a definitive value, it's greater than or equal to 80. So there's our inequality representation. Solving this then, we have a fraction, so the first step is to get rid of the fraction to make this easier to deal with. So every term gets multiplied by 4. This 4 over 1 cancels out the 4 in the denominator. While we're at it, 68 plus 76 plus 78 adds up to be 222 plus the x is greater than or equal to, how about 320? To get x by itself, we'll subtract 222 from each side using our addition principle of inequality. That leaves x must be greater than or equal to, the difference is, they're really going to have to do well, as a minimum they would have to score a 98 or better to pull that grade up to a B. Wishing them much luck.